all these videos. Some of the problems will, of course, be repeated, but between all the classes, you've probably done them all. All right. So which one did you say for?
2A.
2A. Find the exact value of the cosine of 120 degrees. Now, just like most of our regular tests, this is going to be part calculator, part no calculator. This is a no calculator problem. So gosh, what do we do? Let's find the cosine of 120. What do we do? Cadence, put your feet down, please. What? Well, the answer is going to be a fraction, but we don't make this a fraction. No, we draw 120 degrees, which is going to look like this. So always start here, 90, 180, so 120 somewhere in between. Then we drop our perpendicular straight down, right? And what does that make this angle right here? This is the key. You gotta get this angle right here, right? That's 60. There's no formula for that. It's not hard. You just use your common sense. If all the way to here is 180, and I only went 120, then there must be 60 more to go, right? In that whole space. Now, that's a 30, 60, 90. So you gotta remember what your sides are in a 30, 60, 90 triangle. And then you've gotta remember to make anything negative that needs to be negative. So, what's negative in that problem? If you are not in quadrant 1, you're negative. So something's negative. The 1 is negative. The 2, the hypotenuse will never be negative. But these guys can be negative depending on where you are. Now we're ready to go. Cosine is adjacent over hypotenuse, so the answer is negative 1/2. So COA, adjacent over hypotenuse. Right? All right. Who else found something? Kelsey?
Number 3.
3. This is actually exactly what we've been talking about, at least the first part of the question is, what we've been talking about. If I said to you, what's the limit of that? What would you tell me? What's the limit of that? 0. Why is it 0? This is smaller than 1. Now, if the limit is 0, what does that mean? Doesn't that mean we're going down, 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 getting closer and closer to 0? So, are we growing or shrinking? This is a decay. This is a decay because the limit is 0. I mean, it's decaying all the way down. So this is a decay problem. What is the percent of decay? Well, you told me you knew this was decay because that's less than 1. How much less than 1 is it? 27%. Less than 1? 0.27? Less than 1? So the percent of decay is 27%. That's how much less than 1 it is. And then, Hope quit yawning. What is the initial value? 300. Yep, that number up front is the initial value. So what if this had been 1.23? That would have no limit, which would mean, is this growth or decay? It's just growing like crazy, right? That would be the growth. How much bigger than 1 is my decimal? 23%, 0.23. So that is a 23% growth problem. See how it's all tied together? It's all wonderful. All right, who else? This one? 1B is a simplified problem. So who remembers our strategy when we had to simplify this?
Oh,
Ian's your phone in your backpack? Is it? Good, that's where it belongs.
Let's start putting the things over one.
Alright, so we change everything into sines and cosines. If they're already a cosine, I like to put them over one. There's no rule that says you have to do that, but it helps me keep things lined up. So if it's already a cosine or a sine, you don't change it. But what's tangent?
One over
Other way around. Sine over cosine. What's secant?
Sine over, no,
One over cosine, and that one would be squared because it's squared in the problem, and then sine over one.
and then you combine.
Then anything that cancels, we cancel. This is all multiplied. This whole problem is one big multiply. So we can just start canceling. So cancel, cancel. Oops, is that all that cancels?
So sine x.
So we have sine squared. Sine times sine over cosine squared, which is tangent squared. So when we did those problems back a long time ago, those are the ones you guys thought were easy, that kind of problem. But of course, there's stuff you have to remember to be able to do it. All right, who else found something? We don't have to do just the front page. Okay, if you didn't spend any time on it, remember I asked you to do that. That's your job.
6.
Ellie had her hand up. 5. Five is a compound interest problem. And we have formulas for that, which you'll be given. You do not need to memorize this, but you need to recognize that's what this is. Compound interest. This formula is the compound interest formula. So the question says, how much will I have in my account? So what will be the amount I end up with? If I start with 1,600, and my interest rate is 3.1. Now be careful, no matter what kind of problem you're doing, if you're putting an interest rate into the formula, it has to go in as a decimal. So don't put 3.1, put 0.031. Okay, always, it goes in as a decimal. It's compounded quarterly, so n is 4. And I'm doing it for 25 years, so my exponent is 100. 4 times 25. Okay? Now, if you type it in exactly the way you wrote it there, it should all be good. I got $3,462.59.
Yes.
Please make sure that you are typing that in correctly and getting that answer, because you don't want to miss points because you typed it in wrong. Make sure you know what you're doing there. Kelsey?
Number 6.
How many radians is 500 degrees? Anybody remember how to do this? How many radians is 500 degrees? Well, 500 degrees is more than one time around. So if I were drawing it, yes, but that's not my job. My job, you know how pi radians is 180 degrees? Well, I want to know 500 degrees is how many radians. So I don't want to change the 500. I want to keep that angle, which does go around more than once, but I want to know how many radians that would be. Nobody remembers pi over 180 equals x over 500? Oh, yeah, you don't want it backwards. Pi radians is 180 degrees, so how many radians is 500 degrees? So 180x equals 500 pi. So x equals 500 pi over 180. And then we always have to reduce that. A lot of times you'll remember the zeros cancel. Not every time, but a lot of the time. And then we have 50 over 18, which is 25 over 9. So 25 pi over 9 is your answer. Remember, this is a no calculator problem.
You
So
know, just a, you know.
you can't, I mean, you have no calculator, so
Oh.
this is just it, 25 pi over 9. Okay?
No calculator comes with multiple choice, right?
Nothing's multiple choice. This exam is entirely free response. It's like, yeah, it's like a regular test, because we're giving it in a regular class period. You don't have an exam period, we're giving it in a regular class period. So, basically the test is like all of our tests, is 2 pages, basically.
This one, the final only 2 pages?
Yeah, it's 2 pages front and back. So you got a page front and back of no calculator, and a page front and
Oh,
back
the final's
of,
not this one?
no,
Oh.
no.
You want it to be more.
I see the little confused.
You want the test to be more because of the
I see the crazy. You're crazy.
Because if you don't know, like 5 out of 20.
You want a 5-page final? You want a 5-page
I don't have to
free
take
response
it, so
final?
it doesn't have anything to do with it.
Exactly, so why'd you have a comment? Yeah, that's
Like what? She grades like that. It was like,
All right, who else found something? Roland?
let's take a look.
No one has asked for 4a and 4b, which are the logarithm
I was
equations.
asked for 4
One is easier than the other. This one is very easy. You may remember how to solve a logarithmic equation like that. You do it. So it's 4 to the third equals x, so x is 64. That's your answer. 64. You better be doing that. All right, and then the second one, B, is a longer logarithmic problem. Hey. We got a few people in here who need to pass this exam. So even if we don't have to take it, or we don't care how we do on it, we're gonna be quite respectful for the other people. Okay? Thank you. All right, so this one is a little harder, obviously. It's got more stuff in it. You cannot do this. This only works if you have a logarithm equal to a number. This is a mess. The big issue is there are 2 logarithms on this side, and you can never solve a logarithmic equation if you have more than one on the side. So we somehow have to put these 2 together, so there's only one thing instead of 2. That's a minus. Does anybody remember how we put these together in a minus problem? What? Well, no. When you subtract logarithms, you are dividing the numbers, right? Thank you. Did they fix them for you, Charlie?
Yeah, I did at Walmart, 'cause that's where
Oh, you had to go somewhere and get them fixed. I thought maybe Mr. Freegee fixed them. I said that was pretty impressive. All right, so when you are subtracting logarithms, you put them together as a division. If that had been a plus sign, then I would put these together as a multiplication. That should ring some kind of bells. And that equals the log base 5 of 5. Now, once you get to this point where you say the log of this equals the log of this, what just makes sense? That those two things should equal each other? Doesn't that make sense? If the log of this is the log of this, those two things are the same. So x plus 3 over x equals 5. Now notice, Ellie said something about canceling them out. Notice, basically I did. I forgot those, right? They're gone now. But I didn't do that until I had just one on each side. You can't just cancel them out in the original problem. That will not work. You have to put them together first, and then you can drop the logarithms out. Okay, so now multiply by 5. It's a regular equation now. So it looks like my answer is going to be 3/4. All right, that takes care of those two. All right, what else?
We do C.
C is another equation, but it's trigonometric. What's the first step going to be? What? Moving the 4 over. Absolutely, moving the 4 over. Got to get that variable by itself. Sin x equals 3/4. Perfect. Now, what this says is there's an angle out there somewhere, and when you take its sine, you get 3/4. So the first thing you got to decide is where would that angle be? If its sine is a positive 3/4, where could I draw it? First quadrant, absolutely. Everything's positive in quadrant 1, right? Where else? There's another place that the sine is positive. What? Not 3. 2. The sine is positive in quadrant 2 because the sine is associated with y. Cosine is x, sine is y. Where is y positive? Isn't y positive up here? So quadrant 1, quadrant 2, I need to find the angle that has a sine opposite over hypotenuse of 3/4. This is a calculator problem because that's not a special triangle. It's not a 3√2(1) triangle, one of my special ones. So I need a calculator. To find the angle, remember the second sine or second cosine, whatever the function is in the problem. But second sine, inverse is how you get angles. So when I second sine 3/4, I get 48.59. The answers to the question are this angle right here and this angle right here. All right, let's measure the purple one. 48.59, that's easy. What about the red one? How will I find the measure of the red one? It is not 48.59. How big is the red one?
Do you do 180 minus?
I do 180 minus 48.59. That's exactly right. Which will be 131.41. Check my arithmetic.
Yeah, that's right.
So that's a super easy problem, but there's a lot to remember. something. Ethan,
Problem
10?
Yeah.
10 says find side A, and I'm allowed to use a calculator. All right,
What's your
goodness.
Don't we do like the 72 10 over 58 over A?
This is a law of signs problem. So I will say sine 72 over 10 equals sine 58 over A.
Then we cross.
Remember, when you have this kind of information right here, look where I'm pointing, that's a law of signs situation. Right? Okay, so let's see, I'm gonna cross multiply. A sine 72 equals 10 sine 58. And then I'll divide by sine 72, so 10 sine 58 over sine 72. Now, one caution about typing that in, it's fine to type it in just like that, but you have to close the parentheses after the 58. So 10 sine 58, close parentheses, divided by sine 72, I got 8.92 as the length of side A. Right? All right, who else? There's a good variety of problems here. Kyle?
14.
14. Now, 14, I need to modify a little bit for you guys. You are only responsible for amplitude and period. Okay? So, all the rest of the stuff, all you will be required to know are amplitude and period, because that's all we did when we did this. Oh, okay, well then I'm not doing it again. Shame on you for not paying attention yesterday. Okay, next problem. Jose? 13 B. All right, Jose says we're gonna look at 13B, which is find the determinant of this.
Is this A? Is this E?
This is 13B. All right, so who remembers anything? This is not that long ago. Who remembers what we did at the end?
Take out the first column.
Yep, I took these guys right here, and I glue them right here. So 1, 2, 0, 1, 0, 1. And then I start here, always start right here. This is where we start. And we multiply those together. And we multiply these together. And we multiply these together. So I got a 0, and a 0, and a -2, which all adds up to -2. Then I come down here. I got a 0, a 3, and a 4, which adds up to 7. And then what do I do with those two numbers? Subtract them. We subtract them. So our answer is -2 minus 7, which is -9. Okay, who else?
What about A? Is that one?
A is pretty easy. How do we add matrices? Well, we gotta do that, we gotta take the second one times 2. So if I take the second matrix times 2, I'll get 0, 10, 8, and 2. Jackson and Kyle, I don't know what you're doing, but neither one of you is in a position to be blown off review time. If you don't want to participate, I'll send you down the office. I have no problem. I've already passed this exam. I don't, doesn't matter to me. Keep your mouth shut. Kyle Coleman, yeah, I'm looking at you. Keep your mouth shut. Jackson, your mom and I are on speed dial. Right? I don't think she'd be very happy. Alright, so now I've multiplied the second matrix by 2. I've multiplied the second matrix by 2, and now I'm going to add them. And when I add them, it's entry by entry. So it's 1 plus 0, oh, this is not 0. 2 plus 10, 3 plus 8, and negative 5 plus 2. If this had been a subtraction, you would do the same thing, only subtract the numbers instead of adding them. Alright, who else? Ian?
Isn't D an inverse?
D means inverse, yes, so, and it's the inverse of this one. So how do we find, we're doing problem D now, we are finding the inverse of the circled matrix. Charlie?
We switch the 1 and -5 and then 18.
So part of it is, he's exactly right, we take these two numbers and we switch them, just switch their places. And these two numbers, we change their signs, so they would both become negative.
Is this the one we do the fraction?
Yeah, so this is not the final answer. Some of you put this down as your final answer when we took this test, but that's not the final answer. We need to divide by something. All these have to be divided by something. And what are they going to be divided by? The determinant of that matrix right there, the original matrix. And that will be -5 minus 6. When you do the determinant, you multiply these, and subtract them, just like you did over here. You multiply, and subtract, so that's -11. So I'm going to divide all of these numbers by -11. And then whatever you can do to clean it up, you clean it up. So positive, negative. That's about all I can do because nothing really reduces. And that's the inverse. So it is a 2-step process. We get our quests back next time, but I have a few homeworks I can hand out now. So who else has a question? Anybody? Find something else we need to look at. All right, no one, which one? All right, we're looking at number 25.
What? What did you ask? We saw that too.
All right, number 25, here we go. All right, where's number 25? Okay, this actually was on one of the tests we took. This kind of problem, pretty much exactly. This time we have an octagon with these 8 sides. It's drawn for you, and the radius is 10. And your job is to find the area of the whole figure. Okay? So remember, every one of these that I draw in is going to be 10, right? And all of the little triangles that are formed are the same size. So if I can find the area of one of the triangles, and then times it by 8, I'll be done. Agreed? So, let's look at that triangle. What do I know? I know the two sides are 10. Do I know anything about this angle right here? I heard some people saying it's 45. How do we know it's 45? Because it's 360 divided by 8. So the area of the triangle is 1/2 side, sine of included angle. 1/2 side times sine of included angle. So I'll multiply all that together, and that'll be the area of the triangle. Then we multiply that by 8 to get the area of the octagon. And that final answer is 282.84. So the triangle is 1/2 sine. And then the pentagon, the octagon is 8 triangles.
What would be the formula or no?
What formula? Oh, no. No, you get the formulas for sequences and series and compound interest. You need to know those. You're supposed to know them already. Oh my God. Cadence.
Can I do 26?
26? Okay, 26 is the very last thing we learned. How to change these repeating decimals into fractions. Now, this is kind of a hard one. I put easy ones on your quest, but this is kind of a hard one because why? You gotta separate the point 2. The point 2 isn't repeating. So you're gonna separate that point 2, and then you have 0.07, and on and on and on. So this is actually what you're adding up right here. This is what we're gonna use our formula for, from the 7 on. So the formula I use is my infinite geometric series formula, which you'll be given that formula, but you need to know that's the one you use. Your first term is 0.07, make sure you say 0.07. And what's my ratio? What's my R in this problem? What is it? 0.1, yep. Why is it 0.1? 1 decimal place is repeating. Only the 7 is repeating. If the 27 were repeating, it would be 0.01. I like to go ahead and subtract that. You don't have to, but I think it's easier. Go ahead and subtract 1 minus 0.1. And then you move the decimal point 2 places to get rid of the decimal. So that's going to leave us with 7/90. The other day when I did one like this, I got all excited and thought I was done. No, I'm not done. What do I still need to do? I still need to add in my 0.2. So I have my 7/90ths, and then I'm going to add in my 2/10.
So find a
Common denominator would be 90. So I have 7 plus 18, 25. That actually reduces by 5, so that would be 5/18. And this will be on the calculator page. So what should happen if I do 5 divided by 18?
Fractions.
I should get this done, right? And I did. Yep, you got it. 27, since I'm staring at it right here, what's the limit of A? What's the limit of B?
0.
Good. Perfect. What else? Bunch more problems. Page 1. 28. 28, you won't have to graph, but I'm not sure what specific questions you're going to be asked. So what I mean by that is, you need to be able to know how to find not only the vertical asymptotes and the y-intercept, but the horizontal asymptote, the x-intercept, and the holes. You need to be able to find all that information. Because I'll only pick a couple of them to ask, but you don't know which two I'm picking. What are you doing? I need you to pay attention. All right, so you don't have to graph it. I think I will, just to kind of keep track of stuff, but you don't have to do that. So what do I do first? How do I get started?
You read the X's?
What?
The X's?
Oh no, we can't cancel. Is that what you mean? Oh no. No, we can never cancel when we have pluses and minuses in our problem.
Yeah.
We need to factor first. Now, if we can factor and then cancel, I'm good. But we just can't cancel right from the get-go. So what might I want to do? Factor. Yeah, let's factor and see what happens. Well, I factored, but nothing cancels, which means there will be no holes. So if that's the question, if I give you an equation and I say, okay, where are the holes? In this problem, you would say there aren't any, because you have to be able to cancel in order to get a hole. All right, so what else? What do I have? I don't have any holes. What do I have? Look at your problem.
You have asymptotes?
I have asymptotes where?
The X plus 1.
Nope, that doesn't, the vertical asymptotes come from the denominator. So the vertical asymptotes are 3 and -3. Remember, vertical asymptotes are where your problem is undefined. And if you put a 3 or a -3 in for X, wouldn't that cause problems? That means it's undefined. That means it's an asymptote. So those are my vertical asymptotes. So if I'm you and I don't remember that, I'm making a note over here. Vertical asymptotes where denominator equals 0. All right, what else can you tell me about something else here? The horizontal asymptote is the same as the limit. And if I said to you, what's the limit of this, wouldn't you look right here and tell me the limit is 1. The horizontal asymptote is exactly the same as the limit. So I have 2 verticals. You don't have to graph it. I'm graphing it. And a horizontal at 1. All right. What can you tell me about intercepts? Over 9, Cadence, that is the y-intercept. The y-intercept is 0,19. To get a y-intercept, you plug in 0. And if you plug in 0 for your x's, you get 19. All right, what about the x-intercepts? So that's my y-intercept. What about my x-intercepts? Where are they? At 1 and -1. Your x-intercepts are where your numerator is 0, and that's at -1 and 1. X-intercepts are also called zeros because if you put in -1, the value of the fraction is 0. So that's my x-intercepts.
So on the final, you could ask any of these.
I can ask any of those. Yep. On the other review sheet, I asked different than I asked on this original one. Okay, now, you don't have to graph it, but if you did, I think you can see this shape maybe, right? And then you know enough about these, I hope you remember, you have a couple pieces up there like that. That would be the graph. You do not have to graph it on the test. All right? What else? You're all supposed to find some questions that you have. Kelsey, 24. Eli caught 2 baseballs on the first day of the season, 5 on the second day, 8, 11. How many will he have caught altogether if he continues this pattern for 100 days? Okay, well, first of all, what kind of pattern is it? Arithmetic. With a common difference of 3, right? Now, you have 2 arithmetic formulas. These will be given to you, but you have to know these are the arithmetic ones. Now, I want you to read the question carefully. Pay attention to the grammar. Because what you have to decide is, if you're going to use this formula, you are looking for the last term, the 100th term. If you use this formula, you are looking to add all of these up. This is the sum. Okay? So read the question. Which one do you think it is? What do you think is happening? Well, Nolan said you need both, and you do, because this one is the actual answer to the question. How many will he have caught altogether? Doesn't that mean add them up?
Yeah.
The problem is, I know I'm adding up 100 terms, and I know the first term is 2. What do I not know though? I don't know the 100th term. That's what I do. I don't know that number, and I need it. So Nolan says, okay, we gotta pause on this formula and go to this one. So the 100th term will be 2 plus 3 times 99, which is 299, I think. I'll double check that. Okay. Now, what the 299? What is that? What does that represent in this problem? What is the 299? How many baseballs he catches on the 100th day? Right. So the 100th term, the 100th day, he catches 299. Now, I want to know how many he catches all together. So I'm going to take that 299 and put it right here because that's the last term. And then I can figure out, I got 15,050. So you've got to be able to read the question and decide if you want arithmetic or geometric first of all, and then you've got to decide if you want the term or the sum. Okay? All right, so
Did you 16?
16. 32 students in the math class. 17 of them love both logarithms and polynomials. 20 love logs, 22 love polynomials. How many love neither? What do you think is going to be your strategy on this problem? The Venn diagram. You've got the kids that love logarithms, and you got the kids that love polynomials, and then you got the kids that love both. Now, what do we know? There are 32 students in this box. This is the class. 17 of them love both logarithms and polynomials. Doesn't it make sense that the 17 would go there? Now here would be a big mistake. 20 love logarithms. So I put 20 here. Big mistake. Big mistake. What does the 20 represent? The entire L circle. These are the kids who love logarithms. So there are 20 people in this circle. So how many are here? 3. And similarly, there are 22 people in the polynomial circle. So this is 5.
So 7 students.
Now, how many kids are here? 25? But there's supposed to be 32 altogether. So there's 7 of them that didn't raise their hand either time. They don't like logarithms or polynomials. And the question is, how many love neither? The answer would be 7. This is a huge issue, kids. Make sure when you see 20 love logarithms that you understand that's the entire logarithm circle. What are these 3? These 3 love only logarithms, right? Okay, Cadence?
Can we do 21 and 22?
21, a 5-card hand is dealt from a standard deck. What's the probability you'll get at least 3 aces? All right, Cadence, what does that mean? At least 3 aces. So I'm going to deal you, I mean the colors. Can you get 1 ace?
No,
You can get at least 3. What does that mean? Vocabulary
I
wise.
can get more.
You can get 3 or more. So we have a 5-card hand. So we could get 3 aces, or 4 aces, or 5 aces. You can't get 5, right? It's a 5-card hand, but I can't get 5 aces. There aren't enough. So I'm either going to get 3 aces or 4. 2 separate problems. I'm going to do them both, and I'm going to add them together. Because anytime it's this or this, it gets added. Alright? So I'm going to deal you a 5-card hand. 5 cards. 3 of them are aces. How many aces are in the deck? 4, and you're going to get 3 of them. But you need 2 more cards to round out your hand. What are they going to be? Anything except aces, right? So 48, C2. 3 from the ace pile, 2 from the other pile. And what am I going to divide that by? This is a probability question. 52C5. Now that's 3 aces. That's not the answer to the question. That would be the answer if it said exactly 3 aces. But it said I could get more. So what does 4 aces look like? 4C4. There's 4 aces. You want them all. 48C1, because you need a 5th card over 52C5. Your calculator will do all that at once. So if you type this in, hit plus, and then type that in, it will do the whole thing for you. I'm having a rough time with my calculator today. I got 0.00175 as the final answer to the problem when I add it all up. So in other words, Cadence, there is not a very good chance of you getting a hand with 3 or more aces. All right, anybody have a question about that one? This one, these kind of problems are always tricky because we forget about this. The problem doesn't talk about the other cards, so you kind of forget them, but remember it's gotta be a 5-card hand. So you gotta have 5, you gotta get 5. All right, and then what was the other one you wanted? I can't remember what you wanted this problem. 22. Read the question and tell me what is going to be your strategy for this one. Is this another Venn diagram or is this something different? It's a tree diagram. How am I going to structure my tree? I've got this notion of late and not late, and uniform and not uniform. So how am I going to build the tree? What? Uniform's at the bottom. So I'm going to build my tree diagram, and at the bottom of it is going to be uniform and not uniform. Because, isn't that the question? Find the probability he'll be in uniform?
And then late, not late.
And this is going to be late and not late. If a student is late, the probability he's in uniform is 0.38, which automatically means this one will be 0.62. If he's not late, his probability of being in uniform is 0.68, which means this one is 0.32. The probability of being late is 0.24. 24% of the students are late. So the other probability is 0.76. And we want to know probability of being in uniform. So we need this one and this one. Those are the 2 ways we can be in uniform. We can be in uniform this way, or we can be in uniform this way. Okay? So here we go. 0.24 times 0.38. We're going to be late and in uniform, so I'm going to multiply those. Or we're going to be on time and in uniform, so I'm going to multiply those, and I'll just type it all in. 0.24 times 0.38 plus 0.76 times 0.68. I got 0.608. Did you? All right, so what you need to do next time